We are still adding and subtracting algebraic fractions here, but now we're going to look at what happens when we have an uncommon denominator, difference in denominator. And so we look at these two and we have a 3xy and then just a 3x. And if we want them to be the same, the smallest change that we can make to get these both to be the same would be to multiply the second fraction by a y in the denominator. Now we would have 3xy in both of them. Since we're working with expressions, we can't just willy-nilly multiply things wherever we want. We really need to multiply by a clever form of 1, because multiplying by 1 doesn't actually change anything. So if we multiply by y over y, we're really just multiplying by 1, which is okay to do. So that's going to change our numerator and our denominator. And when we do that, we can now write out our new sum of these two. And we have 3xy in the denominator of that sum. In the numerator, we have 3x minus 4y plus 5y. So we have 3x coming first, and then negative 4y and 5y would be plus 1y, or just y. So we have 3x plus y over 3xy. Now, with an answer like this, nothing will simplify because there's nothing we can factor out of the top. There is addition or subtraction going on. There's nothing we can factor out of that out front to cancel with the denominator where everything is multiplied together. So because it's unfactorable, there's really nothing we can do. Looking at a more complicated example, let's scroll down and try number 13. Now there's a few things that make 13 complicated. First of all, it's subtraction. So immediately I want to turn this into plus a negative and make that whole numerator negative, which in this case is just the 3. The other part though is that if I want these denominators to be the same, I see addition and subtraction going on in the denominator. I actually need to multiply top and bottom. If I want to get a common denominator, my common denominator is going to be something over p minus 2, p minus 3. P minus 2 and p minus 3 have nothing in common as groups, as in nothing can be factored out of them that they both share. So the answer is going to have both a p minus 2 group and a p minus 3 group inside of it. The only way we're going to get a denominator like that is if we multiply the top and bottom by whatever one isn't already there. So we already have a p minus 2 group here, so I'm going to multiply the top and the bottom of this fraction by p minus 3. Same idea, I'm going to multiply the top and bottom of this fraction by p minus 2. And what we're doing now is we have two fractions that both have the exact same denominator. If I want to clean up my numerator so that I can try to add them together, I need to distribute my original terms by my new pieces. So I'm going to have 4p, 4 times p, and then minus 12 over here. Cross that out. I'm going to have negative 3p plus 6 over here. Distribute that negative 3. Cross that out. And now I can add my like terms. I have 4p and a negative 3p, so that's just going to be 1p or p. I have negative 12 and positive 6, which is going to be a negative 6. So I have p minus 6 on top. And my denominator stays the same as it was all the way across, my common denominator. And that's going to be my final answer. Nothing can factor out of any of those parts that is in common with each other. Other things to watch out for when you get to complicated ones, if you look at number 17, you'll see an x squared minus 2x minus 15. You could factor this first and then work from there, or you could just realize that there is going to be no common factor and you're going to have to multiply the bottom of this here by x squared minus 2x minus 15, the whole thing, and you're going to have to multiply this whole thing by 6, meaning that you're going to have to multiply this whole top x squared minus 2x minus 15, and multiply this whole top here by that 6. Again, it's subtraction, so we need to make sure we do plus a negative of our original numerator, which is going to be that 4x right there, so make that negative. And now we're going to end up, in this case there's nothing to distribute, just multiply through, but in this case you're going to be distributing all the way across here. And when you get your answer near the end, you're going to end up having this all over one large fraction, and there will be places where you can do a little bit of reducing as well. So this is a very messy problem. There's a lot of things that can kind of trap you there. So just watch out when you get to that one. When you get to problems like this one here, you're looking at what can I factor out of everything, and in my denominator I see a 2n in common everywhere, and when I factor that out I still see more factoring I can do. I see an n minus 5 and an n minus 6 that I can continue to factor with. And at each stage I'm going to cross things out. And I'm hoping that something was going to cancel with that top. It didn't. And because of the fact that nothing actually could cancel, keeping these factorings that I did might not necessarily be all that useful. Since it doesn't reduce anyways, it might be easier to just work with the original denominator right here, to take this whole thing and multiply it top and bottom over here by this 4n, so that we can add them together, and that would be my common denominator then all the way across that I use in my answer. So these can get pretty complicated. Make sure you're asking lots of questions, working with your peers for help, and taking your time with all of these steps. Good luck.